Welcome back to this Insight Space Special as we look back at a year in exploration. The Rosetta Space Probe finally finished its mission this year. Launched in 2004, the probe's objective was to reach and orbit a distant comet while sending back its findings. It took Rosetta and its companion lander Philae a decade to reach their target. They stayed there, sending back data for 2 years before Rosetta began a controlled crash into the comet. Well, Ian, it did exactly what it was supposed to do. It's a remarkable success in that sense.
It was a tremendous success. I mean, I think it's not quite true to say it did exactly what it was supposed to do, because its little lander unfortunately crashed, and so some of the in situ measurements of the composition of the comet that it was hoped we'd get back, we didn't. But the Rosetta orbiter itself was a fantastic success. Yes, there's an enormous quantity of data returned, both in surface imagery, a very high resolution imagery of the surface of this cometary nucleus, but also in situ measurements of the chemical composition of gases that are boiling off the nucleus.
Where's that data useful now? Where does that go? I mean, okay, we get to see a few photographs and go, wow.
So all of these instruments are backed by huge scientific teams whose job it is to sort of interpret the data. So it goes into the scientific community, but the ultimate aim is to determine what comets are made of, and therefore how comets formed, because comets are amongst the oldest objects we've still got that date from the very formation of the solar system. So the main scientific aim is to understand the origin and early evolution of the solar system, even before the planets themselves had formed. But there is on the horizon another aspect. I mean, we're talking about space resources. Comets and asteroids both are potentially very valuable future resources in our future exploration of space. So work done like Rosetta at Comet 67P have this dual importance, really. One is the scientific importance for understanding the origin of the solar system, but there's a more practical importance looming as the future utilising bodies such as comets for space resources.
Do we take heart, Sarah, from the command and control navigation skills? I mean, it was extraordinary, wasn't it, to point this object and get it all the way over there?
Exactly, it's a feat of science, but it's also a feat of engineering, the fact that it's the technical equivalent of landing a fly on a speeding bullet in terms of what engineers are able to do. It really was. It was a decade-long journey across the solar system. The Rosetta spacecraft and the lander Philae were put to sleep. They were then woken up very, very far away from Earth. They then arrived at the comet, managed to go into orbit around the comet. You've got to remember, this comet's around the size of a city. It's duck-shaped. You know, that was one of the most unusual findings. But its gravity is not as strong, and it's really, really, just in terms of engineering, a huge achievement. And often people forget about the engineers because scientists think it, but it's the engineers which enable this to happen.
Without them, we wouldn't go anywhere.
Well, exactly. And another interesting thing, just going back to Ian's point, is actually there's kids who are at primary school now, so 5- and 6-year-olds, who, if they become a scientist, could be doing the PhDs on the information found from this mission. That's how much data we've been able to collect. So yes, these missions are expensive, but the costs are spread across, and the amount of science, technology which is developed from them is just absolutely huge. And there's going to be people studying the research and the results and the findings from this mission for decades to come, and that's a huge achievement in terms of how we progress next in space exploration.
Are there more comets, you think? I mean, obviously
there's
more
many
exploration than you'd love to do, but a lot in parallel with the Mars effort, which we now know is not going to be done by nations. It's going to be done by collaborations between very rich people and nations. But are there other comets which you would say, yes, we should definitely go?
There are billions.
Which ones wouldn't you?
You want to go to them all, I appreciate.
There are billions of comets and billions of asteroids, and they're all likely to have different stories to tell. So there's certainly other comets that one would want to explore.
Well, it's to do with how it's easiest. There's 67P, Churyumov-Gerasimenko, which was the name of the people who discovered it. It wasn't actually the original choice, but it was to do with the actual time of the landing, then the launch, and then the launch got put back, so it was which comet was in the right orbital path. But I think sometimes people forget how massive space is, and as Ian said, there are billions of comets, there are billions and billions of stars, there's billions and billions of solar systems. So this was just one comet out of many, many, many in our solar system. We're really only just starting to scratch the surface in terms of what we're able to explore, and this is the first time we've ever managed to do something like that. So it's a hugely exciting thing.
Sure is. Now, not every crash landing was intentional in the year 2016. The European Space Agency saw their Schiaparelli probe crash land on Mars. The ESA said that the probe suffered a sensor malfunction during its descent, causing the parachute to be jettisoned too early and the landing rockets fired for just 3 seconds. But the lander was only one part of the greater ExoMars mission. The agency successfully placed a probe into orbit, which will now seek evidence of life on the red planet. So, of course, it went wrong, so we want to rush to judgment and blame somebody. Do we blame the software engineers?
I think, let's not rush to... So, Schiaparelli was an engineering test for Europe to learn how to enter and soft land on planetary surfaces, and we didn't quite soft land correctly, right? But a lot of engineering data was returned from Schiaparelli. The early part of its entry and descent and landing sequence was a success. So, it did get confused. It thought it was closer to the surface than it was when it deployed its parachute.
Landed, didn't it?
Well, it thought it had got closer to the surface and got to the point where it could deploy its parachute, and it wasn't. So that was wrong, right? But you live and learn by the mistakes. But I think the engineers will have learned a tremendous amount from the Schiaparelli entry-descent profile. So it's not a complete disaster at all. It will still help pave the way for future European missions to Mars.
And I think the whole story with ExoMars, Schiaparelli lander, actually got a bit of an unfair beating in the press, because I think had it been NASA, had it been America, that had been very clear that this was just a test lander. I mean, they weren't even certain. It was only 50-50 it was going to successfully land. It was, as Ian said, just a tester to see if we could potentially land on Mars. What was hugely successful, though, is the trace gas orbiter, which travelled with Schiaparelli to Mars, is now in orbit around Mars. The main part of the mission was a huge success. It was just the lander, which is a tester for a future lander, which didn't completely land, but it was never meant to last for very long anyhow.
The Europeans being a poor relation in the race, that means they get judged more harshly?
They landed, absolutely not. They were behind the Rosetta mission to a Comet. It's just in terms of Mars exploration, NASA has done more in terms of that, but in terms of other types of space exploration, the European Space Agency, ESA, have done more of that. So absolutely not. And you've got to remember, there's China, there's Russia. America aren't the only players in terms of space exploration. They're just very good at talking about it.
But do you fear for an international space race to Mars? Or do you think there's going to be a more collaborative
I love an international space race. It would drive forward innovation. It won't happen.
Everyone is now reliant on the Russians, aren't they? They do the buses up and down, don't they?
But China's reliant on China. So I think you've got the International Space Station, but China aren't involved in that. And China, you've got to remember, was under the Mao regime when people landed on the moon in the 60s and 70s. Now China have got this, they're very secretive about what they do, but they really are. They've got a space station in orbit now. They've got ambitions to land on the far side of the moon, land a probe on the far side of the moon. Yes, you've got international collaboration, but are you telling me, seriously, if China managed to land on the moon, that America wouldn't want to go back to the moon afterwards? So in an ideal world, everyone would collaborate.
So if we try to look ahead 12 months from today, what do you think we might be talking about? The fact that we're back on the moon surface?
No, not within 12 months.
Not within, but within 12. No, so I think within 12. So there are long-term and short-term things here. In the excuse me. In the next year, China is aiming to return a sample from the moon. Yes. This is the first time rocks will have come back from the moon since the Russian Lunar 24 mission in 1976. So 40 years. China's likely. So then, in the short term, I think it will be interesting to see what the new administration in the US makes of this. It may reinvigorate US interest in the moon, seeing China suddenly very active on the moon. So I would like to think that collaboration in space could still be one of the diplomatic tools that can help build bridges between nations.
You'd hope for more collaboration during the calendar year 2017.
Absolutely, collaboration is key, but I think there is a rise in China, and China aren't currently collaborating with the Americans. And if you're looking at the space superpowers, it's Europe, Russia, China and the Americans, and also India as well, because you're getting developing countries which are now really rising in terms of space exploration. But yes, in an ideal world, collaboration is what drives things through, but so does competition.
Absolutely. Great to meet you. Sarah Cruddas and Ian Crawford. Thank you both very much indeed.
Thank you.
We end, as ever, with our Insight Bite, a little something that we feel you should know. So let's end with one of NASA's most ambitious missions. This year, the US Space Agency successfully placed their Juno probe into the orbit of our solar system's largest planet, Jupiter. The probe, which cost $1.1 billion to build, travelled 1.7 billion miles over 5 years to reach its destination. Juno will circle the planet 37 times pole to pole before making its death plunge into the planet's surface in 2018. It's hoped that studying Jupiter, the so-called king of the solar system, will reveal new information about the origins of the planet. Back to Earth for now. I'm Martin Stanford. That was Insight.
Bye.